Let us proceed. We are on number 27. Number 27 is saying it is given that z minus 2I is a factor of this equation, which is z power 4 plus 13z squared plus 36 equal to 0. Then you have to solve that equation. So our equation is z power 4 plus 13z squared plus 36 equal to 0, where z minus 2I is a factor. So which means that z equal to 2I is a root. So remember, when one of your root is a complex number, another root is the conjugate of that one, which means that if this is z2, our z2, if this is z1, our z2 will be negative 2I. So the conjugate of that one. So remember, when you have two roots, you can form a quadratic equation, which is z squared minus sz plus p. So where s is the sum of those roots, so there it will be negative 2I plus 2I, which is 0. Then the product which is p, is the product of those roots, which is z1 times z2, where it will be negative 2I into bracket 2I, where the answer is 4. So meaning that this quadratic equation will be z squared, our sum is 0, our product is 4. So this is our quadratic equation. But see here, we have power 4. So meaning that we will take this quadratic equation times another quadratic equation to form equation of power 4. So which is like az squared plus bz plus c equal to 0, as this one is equal to what? To 0. So we're going to expand this one. If we expand this, it will be az power 4, bz power 3, cz squared, 4az squared plus 4bz plus 4c equal to 0. So meaning that it will be a z power 4 plus bz power 3, c z squared, we take z squared out of the bracket, it becomes c plus 4a into bracket z squared, then plus b 4bz plus 4c equal to 0. So our polynomial is az power 4 plus bz power 3 plus c plus 4a into bracket z squared plus 4bz plus 4c equal to 0. So we compare this equation with the given one, which is z power 4 plus 13z squared plus 36 equal to 0. So coefficient of z power 4 here is 1. There is a. That's say a equal to 1. Coefficient of, you don't have z power 3 here. So meaning that its coefficient is 0. So meaning that b, our b is 0. So coefficient of z squared here is c plus 4a equal to 13. Then we don't have z here, meaning that its coefficient is 0. So that's why 4b will be equal to 0. Constant 4c will be equal to constant here, which is 36. So what does it mean? It means that our a will be equal to 1, our b will be 0, our c plus 4a is 13, our 4c is 36, which means that our c is now 9. Our C will be what? 9. So now, it means that our equation will be z squared plus 4 into bracket. Our A is 1, that's z squared. I'm using this equation. Plus B, our B is 0, plus C is 9, which is equal to 0. Remember, if you have two equations like this, two product equations equal to 0, this one is 0 or that one is 0, meaning that z squared plus 4 equal to 0 or z squared plus 9 equal to 0. So from this we have the roots, which is plus or minus 2i. Then we're going to use this one. Z squared plus 9 equal to 0. Z squared equal to negative 9. Z will be square root of negative 9. And negative 1 is I squared. So Z will be plus or minus 3i. So which means that there is plus or minus 3i. And there is also plus or minus 2i. Our set will be equal to negative 2i, negative 3i, and 3i. So this is our set. Remember, I got this one from, we given one root, which is, 2i. And I told you when you have a root which is a complex number, another root is its conjugate. So those are, we given one, so meaning that we have another one because it is its conjugate. So we remain to find other two roots, which are plus or minus 3i. So our set contains negative 2i, negative 3i, 3i. I hope you don't have any question. Let us go to number 28. So now we are on number 28. 28a is saying, given that z1 equal to negative I is the root of the equation, which is z power 3 plus z squared plus z plus k equal to 0, and find the value of constant k. So we have z1 equal to negative I as a root. This is a root. So of the equation, our equation is z power 3 plus z squared plus z plus k equal to 0. So if this is a root, it means that when you bring this root here, the answer is what? Is 0. So meaning it will be negative I power 3 plus plus negative I squared plus negative I plus k equal to 0. The answer must be equal to 0. So what is I power 3? I power 3, that is this is negative I power 3. This is plus I squared, because negative 1 squared is positive 1, then minus I plus k equal to 0. So what is I power 3? I power 3 is negative I, that is positive I, because negative becomes positive, minus 1 minus I plus k equal to 0. You see I minus I is 0, remaining with negative 1 plus k equal to 0. So our k equal to 1. So if our k equal to 1, it means that that equation is z power 3 plus z squared plus z plus 1 equal to 0. So that's that equation. So our value of k is what? Is 1. So we are done with 28a. That is 28a. So let us see 28b. 28b is saying, write down the other complex roots of the equation and find the third root, stating whether it is real or complex. We have to state if the third root of this equation is a real number or it is a real root or a complex root. So remember, when you are given a root, as that root is a complex number, another root is the conjugate of that one. So mean that for z power 3 plus z squared plus z plus 1 equal to 0, then z1 equal to negative I, it means that another root is z2 which is I, the conjugate of this one. So, and remember when you have two roots, we use quadratic formula, which is z squared minus sz plus p. So where s is sum is z1 plus z2, and which is negative I plus I, the answer is 0. Then product is z1 times z2, which is negative I times I, which is negative I squared. Negative I squared, that is 1. So meaning that this equation is z squared, our sum is 0, then our product is 1. So which means that this is a quadratic equation, and we have power 3. So we need the linear equation to form a equation of power 3. So which means that z power 3 plus z squared plus z plus 1 is the same as z squared plus 1 into bracket az plus b. So because if we multiply, we'll get a third degree polynomial. So when you expand this one, when you expand z squared plus 1 into bracket az plus b, we're going to get z squared times az, that is az power 3. Z squared times b, that is b z squared. Then 1 times az, that is az. 1 times that is b. So now that polynomial is az power 3 plus bz squared plus az plus b equal to 0. We compare this equation with this one, which is z power 3 plus z squared plus z plus 1. If we compare this equation with that one, you see the coefficient of z power 3 is 1, and there is a. Our a is 1, our b is 1, coefficient of z squared, a is 1, and b is 1. So which means that a and b are equal to 1. So meaning that z squared plus 1 into bracket az plus b, the answer is z squared plus 1 into bracket our value of a equal to 1 and the value of b equal to 1, that is z plus 1. And remember, are equal to 0. So we have two products which are equal to 0, that is z squared plus 1 into bracket z plus 1, which is equal to 0. So remember, when you have two products equal to 0, it means that z squared plus 1 equal to 0, or z plus 1 equal to 0, which implies that z plus 1 equal to 0 implies that z equal to negative 1. So this is the third root, which is real roots. It is the real root. So meaning that our set contains 3 roots, which is negative I and I, then negative 1. So that's the answer. I hope there is no any question here. So let us go to number 29.